Hello everybody. In Learning Education Center platform, today we will discuss physics. We will discuss the topic physics today. So, what basically the physics is, what we will teach in physics, and what are the theories which are getting to be taught in what physics generally. So, physics that includes units units and that includes motion and work, energy and power. So what is basically the units? We will have a general discussion on units also. Today we will discuss the units, but in physics, after studying physics as a subject, because the physics will come in the examinations point of view, competitive examinations, for knowledge point of view, any debate discussions, any research scholars, any kind of knowledge making, knowledge acquiring, knowledge gathering. So for that point of view, physics, if we will study, then we will come to know about some of the topics after studying this course. What are the course outcomes? What is the course outcome of this? That would be, we'll be able to know units, about the various units of the quantities, and then we'll be able to know the motion, what basically the motion is, and what is work, energy and power, what is basically the work, what is energy and what is power, and gravitation, what basically the gravitation is. Because as we already know, every quantity is having its unit, everything which gives moment, or the body or an article which is having some moment like this, some moment that is having a motion, because in motion body swims from, or body moves from one initial position to some final position, or there is a sense of some displacement as well from its position. That is why it is supposed to be the motion. And what else? Work means work means anything which we will do, that is work. Energy, the working ability is calculated in terms of energy. If some object and article is having some energy, then only the work has been done. And what is power now? What is power? If we will calculate energy, then we will also calculate energy is equal to power into T. Let us suppose the power consumption is there. Some power consumption is there in electrical for some period of time, that constitutes what? Energy. And kilowatt hour, that is calculated in kilowatt hour. And power, if it is of active power, it is calculated in kilowatt. What is the gravitation? Now, after studying this gravitation, we'll come to know that, let us suppose some object will fall from top to bottom, from upper sense to lower sense, lower surface. Then at that time, why the object falls from upper to lower? Due to this gravitational field, gravitational pull of the earth, because earth is having a gravitational envelope. There is an envelope of the gravitation of the earth. That is why the object forces from what? Higher surface to lower surface. Now what is pressure? If we will discuss about the pressure, we'll come to know that pressure is equal to force upon area. Pressure is a kind of thrust. Force is also a kind of thrust. But what is the difference between pressure and force? Here is this. Force is a thrust only, but pressure is a thrust in area. In whatever area. Area is what? Length into breadth is supposed to be area. So in whatever area the thrust or force is getting to exert, there is nothing but pressure only. In Hindi it is called dabav or dab. It is called. And what is force? Force, bal. In Hindi it is called bal. So that is why pressure is equal to force upon area. And force is calculated in newtons. The unit of, obviously force is supposed to be Newton, and the unit of area is supposed to be meter square, because area is having some length and breadth. Lambai and chaudai we will say, or in English it is also called length and width. So what is flotation? Flotation here generally means which is related to water surface area. Let us suppose the principle of Archimedes we are going to study in this flotation topic. So what is flotation? Let us suppose suppose somebody is going to throw any object to the water from some height. So it means that the water is getting to be replaced by whatever space that object is of. So that is Archimedes saying in its principle. That is comes under flotation. Flotation means what surface is getting to exert a force back to that object, which is getting to what? Which is getting to on the surface of the water. So that is called flotation. One more thing. So in flotation also we will study the flow area. Whatever by what flow the fluid is getting to flow. And if it is the flotation, if you will do, either we are going to study the sense of flotation in open area or in closed area. That is also a case study. Now at that time we will discuss. Now what we will discuss next is supposed to be surface tension. The tension exerted by any surface, that is supposed to be surface tension. That is why it is nomenclature to be as something like surface tension. So what is viscosity? Viscosity is also there. If any object that is dense means gada. In Hindi it is called gada. It is supposed to be something like more concentrated. So that is suppose having more viscosity because it is having more friction in the layers of the what? Of the fluid or the liquid. That is supposed to be the viscosity. So what is viscosity? We'll study. We'll also study the elasticity. Let us suppose some elastic is there. Some elastic is there. Suppose we are going to stretch any string. So the string has a characteristics to come back to its original position. That is supposed to be what? That is supposed to be elasticity. That is supposed to be what? Elasticity. Because suppose if we will stretch some string, then the string is getting to come back to its original position. That is inertia, due to inertia of rest. That is really called. So that is why it is called elasticity. So we'll come across this after having this course physics. We'll come across the course outcomes of this physics is supposed to be like this. And what next? What next? Wave. Wave is what? What wave is actually moving like this? What wave is actually moving like this? So this is wave. So this is wave. What? Either the wave is supposed to be in what direction? X direction, Y direction. That will be 3D wave, 2D wave, or traveling in two-dimensional geometry or trajectory whatsoever. It is a simple straight wave or something having a transversal wave. Transversal in Hindi it is supposed to be like tirchi. So tirchi waves or something like what? It is having 3D or 2D structure whatsoever. So this is called to be a wave. What is the amplitude of the wave? What is the frequency of the wave? We'll study like this. So we'll learn what are the measurements of the waves, what intensity that wave has, also what density that wave has. We'll study like that. What is heat now? We'll also come across the heat. Heat is having something like thermal conduction or thermal flow. Thermal means heat. So in whatever material, suppose that material is metal. Metal is having a what property of flowing heat from itself. So it means that either the what heat or what thermodynamics is occurring in any material or any system. What is the thermodynamics of the heat flow through the system and the surrounding? What is the adiabatic process? What is Carnot cycle? There are different things which we'll study here in this. What is enthalpy? What is so because we'll study this heat portion also in chemistry as well, but in physics portion, what basically we'll study that what is the heat conduction and the heat flow, what basically the Seebeck effect is. Let us suppose there is material and there is some more material is here, and one material is supposed to be very heated and some material is having least heat. So the more heat or the thermal flow is from higher heated object to the lower heated object. So till the equilibrium is supposed to attain. So that is why it is called to be as the heat flow. This will thermal flow we'll say. So light, what is light? What is reflection? What is refraction? Reflection means turning back of light. That is reflection. Refraction means crossing or the passing of the light from one medium to another medium. That is supposed to be what? Light. Light may, in refraction also, there would be some denser medium here, rarer medium at the other side. It may be possible the rarer medium here, denser medium at the. Denser means more close and compact, and rare means light. That is why. So by what medium the light is getting passed, we'll study here. In light also, we'll also discuss the sense of optics. What is mirror formula? What is lens formula? What is concave lens? What is convex lens? So these are some of the topics we'll discuss in this light area. Now what is electricity? So how the electricity is getting to flow? What is current I is supposed to be? Because current is nothing but rate of change of electron with respect to time, that is supposed to be current. So if electron is getting to flow from one position to another position, let us suppose, then current is getting to flow, or the assumption of the current is supposed to be there. So what is basically the electricity is, and if the charges that are not if they are not revolving around, or they are just at their position, they are static, that is called electrostatics. If the electrons are moving from their place to another place, that is called electrodynamics. So we'll study electrostatics, we'll also study electrodynamics in electricity. In current also we'll study something like what basically the DC circuit is, what is AC circuit. However, we'll discuss that in electrical engineering as well thoroughly. But in physics point of view, we'll discuss likewise here. We'll discuss some of the bridges portion. What is Wheatstone bridge? What is galvanization? What is galvanometer? What is sensitivity? Sensitivity here means the change of output, sudden change of output with respect to the change in input, that is supposed to be the sensitivity. Or sensitivity in terms of voltage. If there is a minute change in the voltage as an input, then definitely the voltage is getting to be changed as an output. That is sensitivity. Sensitivity means samvedanshilta of any instrument or whatsoever. So this is what electric. Magnetism is what we will study in this, the magnetic field, as we discussed in electric field, the electrostatics or electrodynamics in electricity, or electric field which is having also the sense of capacitor. In magnetism we will study inductor. The charge stored in the inductor is supposed to be in terms of magnetic field. So magnetism here means what is Faraday's law of electromagnetic induction. What is basically here, E is equal to, let us suppose E is equal to minus d phi upon dt. It means that what is the rate of change of flux. Phi means flux. Flux in Hindi it is called magnetic lines ka bahav. So it is called what is the rate of change of flux with respect to time, that is constituted to be as electric field. Why this minus sign? Because whatever EMF is getting to induce after rate of change of flux, d phi upon dt, E is equal to minus d phi upon dt. Whatever rate of change of flux with respect to EMF, that is of that opposing nature, that is called Lenz's law. That is called what? Lenz's law. So we will study in this magnetism, Faraday law and Maxwell equation we will also discuss. Atomic and nuclear physics. In atomic and nuclear physics, we will discuss about the atoms, its position, what is orbital, and likewise, and what is nuclear physics. Will X-ray we will discuss here also. We'll discuss many more things here also. Nuclear reactors and nuclear fission we will also discuss. In electronics also, what is electronics basically? If you will see here, then electron plus mechanics. Electron plus mechanics, that is called to be as electronics. Electron, the mechanics of electron is supposed to be electronics. It means that the movement of electrons, or the action of electrons, whatever, that will constitute to be as electronics. Electronics is having some diodes, transformers, and diode and transistors. Transformers is having an electrical, and diodes and transistors, and either it may be BJT or it may be FET, like bipolar junction transistor, it may be field effect transistors. So there are different kinds of transistors here in electronics we'll discuss, like PN junction diode we'll discuss, the VI characteristics, the voltage and current characteristics, what a diode constitutes, we'll study in this electronics. So this is all about the outcomes or the course outcomes of this physics, what we will discuss. Now, what is the point of discussion here is this, that units, what basically the unit is. What is unit? So today's topic we will discuss with the first topic, that what is units. So unit here means the chosen standard, used for measuring a physical quantity. There are different physical quantities. What are those physical quantities? That may be length, or that may be mass, that may be time, electric current, temperature, luminous intensity, and amount of substance. So these are some of the physical quantities, or there are many more quantities like force is there, pressure is there. There are many more physical. However, these are some of the basic quantities, basic 7 quantities here. So physical quantities is having whatever standard, in whatever standard those physical quantities getting to express, and by what, and that constitutes in measurement, that is called to be as units. And for a unit, for becoming a unit should be what characteristics a unit should have. A unit should have a well defined unit should be there. Unit should be very well defined, clearly defined. And what next? Easy to reproduce. It would be easy to, if it is again way to produce, it's too simple to reproduce any unit. That is constitute to be a characteristics and property of this. And what next? Easy to compare. Let us suppose we would like to compare any physical quantity, then it should be easy. It should be not too cumbersome to compare. So that is why it is called to be as easy to compare. So internationally accepted. The unit should be internationally accepted. Unit should be such that it should be internationally recognized, it should be admired, and definitely it should be what? Internationally accepted. While an internationally accepted unit is supposed to be something like the SI unit, the standard units, international standard units, or standard D international it is called in some more languages. So independent of changes in physical condition. In physical conditions, in whatever physical condition, it should be what? Independent of changes. It should be the main characteristics of units. So now there are different physical quantities here, and the SI units and their symbols we generally hear. So what is this? Length is to be measured in meters, and it is to be symbolized in m, small m. Something like mass. Mass is what? Mass is the content within the body. However, we have one more lecture, additional lecture towards this mass and weight and all whatsoever. Now we will go through. So physical quantity, mass is means the content, whatever any object and article has, that is supposed to be mass, whatever. Suppose somebody is saying there is a wood. After getting fired to a wood, there is an ash. Okay, there is now that ash. Let us suppose go back to some river areas, or so. It will take some time. It will take some space. So it is having some. It is a matter. Matter is one which will take space. That is why. That is why mass can never be zero. There is a minute scaling. Yes, mass cannot be zero. It cannot be zero. Once the thing exists in the universe, it should not be zero. So that is mass cannot. However, the weight may be zero. We'll discuss in further units. That is what measured in SI unit. That is kilogram. Mass is having a SI unit of kilogram. That is measured in kg. Time is having a SI unit of second. That is measured in s. And electric current is having a SI unit of ampere. A-M-P-E-R-E. And expressed in symbol as capital A, and temperature is having Kelvin, and what? K is the symbol. Now let us suppose somebody will say 10 degrees Celsius. If degree Celsius means 1 degree Celsius is equal to 273 Kelvin. So if 10 degrees Celsius has to be changed in Kelvin, then 1 plus 273 Kelvin. It's 10 plus 273 Kelvin. Then it is comes to be 283 Kelvin. So 10 degrees Celsius is 283 Kelvin. This is very important to know. So let us why temperature is having Kelvin as a unit, as a unit, and what symbol K is there. So now luminous intensity. Luminous means chamakdar, and intensity means tivrata, tikhapan. So that is called to be as intensity. That is measured in SI unit as candela, and CD it is the symbol. And finally amount of substances, how many, what amount, by whatever quantity, किस मात्रा में any substance, कोई भी तत्व किसी भी quantity में कैसे है. So that would be what? That would be unitized as mole, M-O-L-E, mole, and definitely MOL is the symbol of this what amount of substance. Now this is quite obvious to know about this. What is CGS system? What is MKS system? Because CGS system is also there. The measurement system are of 4 types: CGS system, MKS system, FPS system, and SI units of systems. So these all systems will work on MLT, mass, length, time. Suppose in some areas, let us suppose there is a cake. which we eat generally, and cake in our birthdays, and also let us in some functions also we just cut the cake ceremony also. So let us suppose having a cake. So what is having, what is, it means that that cake is measured in what, pounds. Pounds is also is having a unit of mass, but mass is also categorized in kilogram. So in some areas, some systems may be used earlier CGS, MKS, FPS, SI. But nowadays, what recognized system is system the international, that is SI unit of system, that would be categorized or that would be accepted universally. So that is seems to be the complete somehow the summary of what units. However, force, if we will discuss about the force then, and in Newton is the SI unit of force, and work, if you will see, the joule is the SI unit of what, force, and urge is the what, CGS system of work, and CGS unit of force is supposed to be dyne, D by any dyne. Okay, so these are some of the things we will discuss about the units and the physical quantities. There is a unit symbols, different kinds of system like CGS system, MKS system, FPS system, and likewise SI system. And we have different course outcomes of this physics. We were just listen. If you will have a quick look on this topic, then in this in the core educational in the learning education center platform, the discussion today will be on physics. In physics, we will discuss about these course outcome like units: motion, work, energy and power, gravitation, pressure, floating, surface tension, viscosity, elasticity, or we will discuss moment. Yes, we will discuss something like inertia also within this. Wave will discuss, and heat, light, electricity, magnetism, atomic and nuclear physics, and electronics. Yes, we'll discuss here. Today's topic is supposed to be like unit. Unit is a chosen standard for measuring some physical quantity. What are those physical quantities? Length, mass, time, electric current, temperature, luminous intensity, and amount of substance. And what are the SI units in context to inverses of these physical quantities? Length is having a SI unit of meter, mass is having a SI unit of kilogram, and time is having a SI unit of second, and electric current is having a SI unit of ampere, and temperature is having Kelvin, luminous intensity is candela, amount of substance is having a SI unit of mole. And definitely if you will going to symbolize this, m, kg, second, ampere, Kelvin, and candela, and then mole. Now what we will discuss is what kind of unit should be. Unit should be well defined, should be easy to reproduce, should be easy to compare, internationally accepted, independent of changes in physical quantities. So this is all about, this is something about what units, and we will discuss these course outcomes one by one.